Welcome to myprojectbazaar.com. Now we can going to discuss about the project determining optimal buses for implementing demand response as an effective congestion management method. Now we can going to discuss about the abstract of our project. In congestion management based this process, we can the two main categories and can find out the analysis: available transfer capacity and a dynamic DC optimal power flow problems. So this is the main of the this of congestion management process. We can using the firefly algorithm to find the demand response to count the effective congestion management method in power system. So demand response programs implemented as one of the main challenges for a power system operator. A new procedure has been developed by which optimal locations and time of congestion management implemented as optimal buses identified the based on power transfer distribution factor and available transfer capacity and DC optimal power flow also. Applying this method, we can use the reduce the lines and the congestion management for improve the load curve characteristics and line outages and prevent the network reliability management. So we can apply the data of IEEE 39 bus system. We can use that and the effective manner we can apply the proposed system. Now we can going to discuss about the flow diagram of our project. First we can process the IEEE 39 bus system. We can input of the data. So this is a bus data, line data and generate data will this in this IEEE 39 bus system is passed to the data functions. Data functions is nothing but we can process the we can read the line of I need the voltage or angle, whatever we can call the generation of data function, we can call that. Next we can pass it through the tested on 39 bus system of dynamic DC optimal power flow. So this is an DC optimal power flow process. We have to apply that to convert the optimal power flow to dynamic DC optimal power flow processed to, through the available transfer capacity and power distribution factor capacity also analysis. This is the main role of this process. So because of we can line to 3 to 2 how much we can consume the power and real and reactive power of this analysis. So we can this analysis proportion very important to that to plot the load curve of this analysis. Again it will down arrow, we can pass through the firefly algorithm. It's an optimal real power loss and reactive power loss is very reduced to do, and how much you can analysis to firefly algorithm, what can process the entire optimization of the algorithm of firefly. So this is an algorithm steps of these two results analysis purpose. So these are lot of results and analysis for that based on congestion management. For our objective functions also constrained to use the different blocks and different parameters. So we can use that drawn the load curve also. Now we can go into running procedure of the project. The proposed system implementation done in MATLAB version 2013A. First you open MATLAB window and create a new script file. We can create an coding for the main file of data sets and the firefly algorithm. After we can this is one of the sub functions also. Next I will show the running procedure of this process. Run. When executing, first we can see the result of this is on real power congestion management using our firefly algorithm. So first we can see the entire lines. We can see it 2 to 30 line. We can optimize data for that, and there is an per unit optimization and the real power injections of this data. So we can how much located the different types of parameters to better results to apply that different lines. So this is a real power congestion management using of the firefly algorithm. What we can locate it in best location for the place in congestion management system. We can line number 16 to 24 is an best location for that. Is an angle and is an optimal value per units. So this is an without DR. Without DR means demand response is not, so we can not connected in load. This is similar to the ATC also. Line 2 to 3 is on this value will occur this between these values we can use of the congestion management without DR. Now load is not connected, so demand response is not applied that. This is an after DR, or this is in the available transfer capacity of also we can use the demand response in hours in the values are based on per unit, so that is on this is on base of our hours. Next thing we can show the load curve after demand response. I can see the first the initial demand. This is an load curve of initial demand. After we can the load curve of the demand. Combine that. This is a fitness functions value. So we can use the 50 iterations and how much we can fitness the values using plotted the graph. This is an after DR plot bar graphs as different plotting, different amplitude ranges. We can see the different ranges of different bus systems. Yes.